Hi, I am Julian Arparco and I am going to discuss about portal method and Castigliano's Theorem method. So what is portal method? According to Civil Digital, the portal method is an approximate analysis used for analyzing building frames subjected to lateral loads such as wind loads and seismic forces. Since shear deformations are dominant in lower structures, the method makes simplifying assumptions regarding horizontal shear in columns. Each bay of a structure is treated as a portal frame and horizontal force is distributed equally among them. So there are three assumptions in portal method. The first assumption is the points of inflection are located at the mid-height of each column above the first floor. If the base of the column is fixed, the point of inflection is assumed at mid-height of the ground floor columns as well. Otherwise, it is assumed at the hinge column base. So the second assumption is points of inflection occur at midspan of beams, and the last is total horizontal shear at any floor is distributed among the columns of that floor, such that the exterior columns carry half the force carried by the inner columns. So the base for this third assumption is the frame is composed of individual portals having one bay only. So this is an example of real structure, and this is how you do an approximation in portal method.
Hi, I'm Nathan Paul Toledo. My report is portal method.
This is some example of portal method. Imagine natin is meron tayong bungalow or one-story building. So para makuha natin yung each rotation nito is meron tayong 4 steps, which is column shear, column moment, girder moment, and girder shear. First step is kunin natin yung column shear. So paano natin makukuha yung column shear? So para makuha ang column shear is meron tayong i-divide natin yung value ng horizontal sa low horizontal. So paano yun? Meron tayong double shear dito. So kaya nga para makuha yun is meron tayong single shear, double shear, single shear. So para makuha tong column shear na to is ipag-add natin tong mga shear and di-divide natin sa 20. So 2 plus 1 plus 1 is 4. And ang value ng ating horizontal line is 20. So, para makuha natin ng shear na ito is divide natin sila both sides by 4. So, 4 divided 4 is cancel ng 4. May iwan is V. So, in terms of kilonewton, 20 divided 4 is 5 kilonewton. So, meron na tayong value ng ating column shear, which is 5 kilonewton. So, paano naman kapag double shear? Sa double shear is dodoble lang natin yung value nitong single shear, which is 5 plus 5 is 10 kilonewton. So, dito, same value lang rin sila ng single shear. Since tapos na tayo sa column shear, punta na tayo sa column moment. Sa column moment, ang rotation natin dyan is counterclockwise. So, this is 4 meters. Ang kukunin lang natin is yung kalate para makuha natin yung value ng rotation. So, this is 4 meters. Kukunin natin kalate. Gagawin natin 2 meters. So, 5 times 2 is 10 kilonewton meter. Dahil 10 kilonewton meter siya kasi moment. Since same lang sila ng rotation, same lang rin sila ng value. So, 10 kilonewton meter. So, dito double shear is 10 times 2 is 20 kilonewton meter. So, after natin sa column moment, punta na tayo sa girder moment. Ang approximate kasi dito is kung ano yung ginawa nating rotation dito, ganun din yung gagawin natin dito. Pero dito is clockwise siya. Ayan. So, ano yung value dito? Ang value dito is same lang sila ng value ng column moment, which is 10 kilonewton meter. Dahil same reaction lang sila, same lang rin sila ng value. 10 kilonewton meter. Ano talaga yun dito? So, paano naman to? Meron kang horizontal and vertical reaction. So, para makuha ang reaction na to is, gagawin mo is ganito. Kapag ang 10 kilonewton mo is horizontal and ang 20 kilonewton mo is vertical, ang mangyayari is, para makuha yung reaction na to, gagawin mo ay pag-subtract mo yung horizontal and vertical reaction. So, 20 minus 10 kilonewton meter is 10 kilonewton meter. Same value na lang rin sila. Last is yung girder shear. Sa girder shear kasi is madali na lang siya. So, ito yung girder shear natin. Dito. Ang mangyayari is, yung girder moment na value is i-divide na lang natin siya sa 2 meters, which is 10 divided 2 is 5 kilonewton meter. So, ganoon na lang yun kapag girder shear. Thank you.
Castigliano's Theorem method. Castigliano's method is named after Carlo Alberto Castigliano. It is a method for determining the displacement of a linear elastic system based on the partial derivatives of the energy. He is known for his two theorems. The basic concept may be easy to understand by recalling that a change in energy is equal to the causing force times the resulting displacement. Therefore, the causing force is equal to the change in energy divided by the resulting displacement. Alternatively, the resulting displacement is equal to the change in energy divided by the causing force. Partial derivatives are needed to relate causing forces and resulting displacement to the change in energy. The Castigliano's first theorem is for forces in elastic structure. It is a method for calculating forces in an application for his first theorem, which states, if the strain energy of an elastic structure can be expressed as a function of generalized displacement, then the partial derivative of the strain energy with respect to generalized displacement gives the generalized force. So this is its formula. Castigliano's second theorem. It is for displacement in a linear elastic structure. This method is for calculating displacement in an application for his second theorem, which states, if the strain energy of a linear elastic structure can be expressed as a function of generalized force, then the partial derivative of the strain energy with respect to generalized force gives a generalized displacement in the direction. So this is the formula for the second theorem of Castigliano.
For Castigliano's example, imagine a cylinder attached to a fixed wall with constant diameter of 4 cm and length of 2 meters and a torque of 8 Newton meter is applied. Assume G is equal to 120 gigapascal. To find the displacement of the cylinder, we will use Castigliano's theorem with the strain energy for torsion. Deflection is equal to partial derivative over partial derivative of torque multiplied by the integration of t squared dx all over 2 times modulus of rigidity multiplied by polar moment of inertia with upper limit of L and lower limit 0, with J is equal to pi over 32 d raised to 4. The area and moment of inertia are not changing, so we can easily find the displacement. Because differentiating and integrating are linear operations, the partial derivative can be placed inside the integral. We can easily solve this equation by using this formula. And by substituting the given values, we have torque is equal to 8 times our length is equal to 2 all over our G is equal to 120 gigapascal times our J, which is equal to pi over 32 times our diameter raised to 4. So deflection is equal to 5305 millimeters.